The ability to make wise decisions, to escape danger, to recognize and overcome obstacles, all of this is based on our human intelligence. But what if this intelligence is no longer exclusive to us humans? We don't know. But now, in the era of so-called AI, these technologies are supposed to support humans as co-pilots, taking on as many tasks as possible, and possibly even piloting themselves in the future. From the smart assistants in our pockets to the advanced algorithms that make our lives easier, AI is everywhere, even in traffic. Making mistakes is human. But can artificial intelligence also make wrong decisions? Can we rely on it at all? Do you think you can outsmart AI? Artificial intelligence enables computers or machines to perform tasks that previously required human intelligence. It can perceive the environment, make decisions, or communicate with humans. AI systems learn from experience and can improve by analyzing large amounts of data and identifying patterns. This ability is often achieved through neural networks. A neural network is like a brain for computers, consisting of many small parts called artificial neurons. These neurons work together to process information, similar to how our brain does. They receive information, process it, and then give a response. During training, they get better at recognizing patterns in the data and ideally finding the right answer. ChatGPT also relies on a complex architecture with many such neurons. AI also plays a crucial role in traffic and is used for assistance systems. New cars must now be equipped with many assistance systems as standard. They provide decision support and take control in certain situations to support drivers and increase safety. Many of these systems, such as emergency braking assistance, fatigue assistant, emergency lane keeping assistant, or speed assistant, rely heavily on camera image data, such as traffic sign recognition for speed adjustment. Currently, most driver assistance systems are designed to keep the responsibility with the driver. But how does such a system actually work? And can we rely on its suggestions to understand how AI works in traffic? We need to take a closer look at the principle of AI. Here's an example. How does AI recognize a cow in a field in a picture? Quite simply, it's been shown many pictures of cows and many pictures of fields. From this, the system learns and identifies patterns that are always the same. However, this mindset can also lead to situations where, for example, a picture with a bus at a bus station is identified by the AI as a cow in a field because the same pattern exists somewhere. The same applies to sign recognition in a vehicle. The AI was first fed with many photos and videos from real traffic. The information contained details about the existing traffic signs, such as position or traffic sign class. This makes it very precise and reliable in its decisions. However, if the AI hasn't seen enough examples of a particular sign, or if the sign has been manipulated, incorrect decisions can also be made. But where are the current limits of traffic sign perception? And do humans and AI make different mistakes with difficult-to-recognize traffic signs due to deliberate manipulation, but especially due to factors like weather, lighting, wear, and tear? For these reasons, we, Risk Software GmbH, have built a demonstrator. We equipped the vehicles of a Carrera racetrack with a camera and our own AI. The AI recognizes traffic signs next to the track and automatically adjusts the speed. By changing digital traffic signs, you can find out when the AI is mistaken and the car flies off the track. Especially because assistance systems are often used very thoughtlessly, you can experiment with how something actually behaves. The basis for trust in these systems is an understanding of how they work. A normal 30 km/h sign can be easily recognized by the AI. You can see that the AI focuses only on the 3, mainly in the lower area, and thus knows immediately that it is a 30 km/h sign. This already shows the difference to human thinking. While we perceive the overall picture, the AI focuses more on details and primarily looks for features that distinguish signs from each other. In the case of a sign with an attached sticker, everything also works perfectly. In the case of a sign that has been sprayed with graffiti, the AI also makes the right decision, which would be almost impossible for us humans in that case. An AI can also be targeted with deliberate attacks, so-called adversarial attacks. The AI's knowledge is used to manipulate those areas that are most important for recognizing the respective class and sign. It's evident that the system then makes no correct decision with this disruption, although it appears relatively easy for our human intelligence. The AI also recognizes a snow-covered sign. However, it has problems with a sign with rotated numbers, although it is quite easy for us to recognize. There are many more scenarios like this, and it becomes apparent that AI differs significantly from human thinking. The recognition and interpretation of traffic signs take place in several steps. First, the environment is captured by the camera on the vehicle. Then comes the detection, locating the signs in the image and rough categorization into prohibition or danger signs. In the next step, the traffic sign is precisely classified, determining whether it is a 50, 100, or another speed limit. Then, the recognized traffic sign is output. For the training of the detection model, the ATSD, a special training dataset created jointly with the ASFINAG, was used for Austria. The dataset contains traffic scenes and traffic sign cutouts from Austrian highways. For classification, we recorded our own training data directly with the race car. The quality and quantity of the data are also important. Too little or wrong data does not lead to the desired result, and the AI makes fewer good decisions. Traffic sign recognition is a significant challenge due to the variety of different signs. Many images from different countries are necessary for this. Additionally, AI systems can be deliberately deceived because no AI is perfect. They are getting better all the time, and the boundaries can always be extended. But there will always be limits.
Risk Software GmbH.
Risk Software GmbH has already made significant progress in 2 research projects to improve road safety.
Einerseits
On the one hand, to strengthen trust in driver assistance systems, and on the other hand, to increase safety on highway construction sites for both drivers and workers.
für die Arbeitnehmerinnen zu erhöhen.
The future of automated driving could be in the hands of AI. But of course, we must be aware that, despite the radical progress, we should not rely 100% on this technology. Developments are advancing rapidly, especially from large language models, the most well-known AIs. And we will also witness a new era of mobility. In conclusion, we can say this. This video was scripted and spoken with the help of AI. But the question remains, who will ultimately have control and responsibility? The machines or us humans?